I was all set to say dzień dobry to show off my Polish, but now it's clear that I don't
Yeah,
understand
it was dzień dobry actually.
Okay.
Yeah.
Anyway, good afternoon. My name is James Kretchmer, and I am at Akamai Technologies, where I am Director of Technology for Europe, Middle East, and Africa. Hopefully you know of Akamai Technologies. We're the market leader in content delivery networks. And historically, that's meant for us accelerating content, accelerating websites through getting it across the internet faster and getting to the end user faster in a kind of traditional way. But today I'm going to talk about accelerating traffic for mobile websites in a new way. This is going to be a lot more front-end oriented, so hopefully that's exciting for you, and it's exciting for us. So a little bit of an agenda. First, I'll talk about the value of mobile optimization, or optimization in general. Why does it matter as opposed to just being a nice thing to do? Well, we don't like slow, but this is actually important. Then we'll talk about why mobile is different and how it's different from the desktop environment and has its own challenges. We'll take a quick introduction to front-end optimization techniques in general, and then look at specifically how to apply them to your mobile sites. And we'll go through specific techniques. And this is cool technology, so it's exciting stuff to see. And then the very last thing is we'll talk about automated front-end optimization as opposed to manual front-end optimization. Now, there's a lot of stuff, a ton of content, so I'm going to go fast. Stick with me, and hopefully we'll get to see all of it. So first, the value of optimization. Why do we really care about this stuff? Well, Akamai's done a lot of studies on this, and one thing that we know is that slow pages actually have fewer visitors. If you have a slow site, people come, but then they leave. They don't stay. They might not even stay for the first page to load if it takes a really long time, but then even if it continues to be slow, they're going to go to another site. And actually, it gets more specific than that. As opposed to just, do they stay on the site or not, we know very specifically that sites that are more performant and that are faster get higher conversion rates. If you have an e-commerce site that's quick and speedy, users are much more likely to make a purchase. And this graph here is showing that effect. And you can see that it's probably a little hard to read, but when you're loading your page in 0 seconds to 1 or 1 to 2, you have a much, much higher chance of someone making a purchase than if you start to take 2 to 3 to 4 to 5 or more seconds. The likelihood of a purchase is much less. So accelerating your site is not just kind of nice because you feel like you should do it when it gets too slow. Even when it's in that middle range, a little increase in performance can mean a big increase in visitors to your site or the revenue that you would produce. And finally, there's user expectations, right? This graph is showing at the bottom that the vast majority of end users are expecting a page to load in 2 seconds or less. Okay, if you go 3 seconds, there's a whole bunch more people that are okay with that, but you can see after that, you really taper off. Most people are not willing to wait a long, long time for their page to load. And the one thing I actually forgot to add a slide on is this is why optimization is important, but why mobile optimization? Why the focus on mobile? Well, the mobile traffic is increasing really dramatically. So we see the proportion of visitors to a site that are coming from a mobile device now is growing and growing. And so the mobile devices have their own performance concerns, and they're more and more of the visitors to your sites. So that's why we're worried about mobile in particular. So that segues right in. What is it about the mobile web that is unique? All right. Well, there's a lot of things different between mobile and different. You have browsers, you have networks, you have a lot of factors. You have screen size. But some of these affect performance very specifically. And so those are the ones we're most interested in. Figure out which ones affect your performance, and then we know how to improve performance. So we'll look at 2. There's a lot we could look at, but we'll narrow it down to some of the most likely culprits. The CPU difference between a mobile device and a desktop device is different, right? What I can do on my iPhone in terms of computation power is not the same as what I can do from my nice, really fast desktop. And the network, of course, is very different in those 2 situations. So starting with the hardware. So this is looking at performance differences on the CPU on different versions of hardware. At the very bottom, we have an iPhone 3GS, then an iPhone 4 above it, an iPhone 4S, and the very top line is a 2-year-old MacBook Pro. Now, between the 2-year-old MacBook Pro and the iPhone 4S, there's already a 10 times performance improvement. Or, looking at it the other way, if you're coming from an iPhone 4, a 4S, instead of a desktop, it's 10 times slower, the CPU. And by what metric? This is a JavaScript benchmark, right? So this is exactly where you care about CPU the most for a website. That iPhone 4S is running its JavaScript 10 times slower than the desktop. And then it just gets worse. Your users on iPhone 4, 37% worse. iPhone 3GS, another 25% worse. So if you look from the iPhone 3GS up to the MacBook Pro, that's like a 20 times difference. So your JavaScript is going to matter here. All right. This is one other way to look at it. The interesting thing here is we're looking at that same JavaScript benchmark, but we're comparing it against page load time. And we'll get into page load time in a little bit. But it's showing that, yes, the benchmarks increase a lot, but the actual page load time isn't quite as bad as the benchmarks. So while there's an effect, it's maybe not the most killer effect. We have to worry, but we're not terrified. Okay, network. What about network considerations? Cellular networks, we know, are not great. They're low bandwidth, and on the low end, it's very low bandwidth, right? We have promise of really speedy 4G, and maybe that's going to make everything great and wonderful, but honestly, we're not there yet. First of all, it's not in a lot of places, and even when it is, it's not that super fast. So we don't have great, and on the low end, it can be very, very slow. Bandwidth is a concern. High latency, and this is one that gets forgotten. High latency can be killer. It's hundreds of milliseconds on a cellular network, as compared to on a desktop. If I have, a decent connection to the internet, I'm talking tens of milliseconds. And now I'm hundreds, maybe it's 200, 300. It's a big difference. So we have to look at that. And then also packet loss as well. So everything's worse. But which one matters most? And what do we need to optimize for? So this is a really nice study. This was done using the top 100 websites, by one study's metric of the top 100 websites. And we look at what is the page load time by the bandwidth of the device that's connecting. Okay, so on the right here, this x-axis has megabits per second. So we see 20 megabits per second. It's kind of a fiber connection. And the page load time is pretty quick, 2 seconds. And as we move over to the left, our bandwidth is decreasing. So we go from 20 megabits down to 10, 5, 2.5, 1.5, and then half a megabit. And obviously, the page load time goes way up. It goes, half a megabit up to 12 seconds to load that one page. Okay, so this is kind of what we expected, but how do we bring this to reality? Here's what's important. Fiber, super fast. Cable modem, okay, super fast. DSL, okay, we took a hit. We're loading in 4 seconds now, 4 or 5 instead of 2, so it's slower. The average cell connection is still slower. It's maybe like 6, 7 seconds now, but it's not super far from the DSL. But the poor cell connection is much, much worse. So I have that phone and I'm in a really lousy connectivity place, or I just have a network that's slow or congested. I'm going to have a really, really hard time loading that page. Now let's compare this. This is bandwidth, remember. But let's compare it to latency. Now this is the latency graph. The orientation is flipped, so as latency goes up on the right, the page load time goes up. And on the left, we have the low latency types of connections: fiber, cable modem, DSL. And as before, we see a slow increase in the time it takes to load that page, from 2 seconds up to 4. But the big difference between this graph and the last one is what happens between DSL and your average cell connection. On the previous graph, it was a little jump from DSL to average cell. Here it's huge, right? The latency difference on just an average cell phone connection made the page load time go from 3 seconds up to 8. And then poor cell connection was even worse. So latency is a real killer. Okay, what about packet loss? So MIT and Akamai did a study together on this. Just to go through it very quickly, looked at lots and lots of connections all over the world, compared loss for mobile versus non-mobile sites or non-mobile connections. And we found most connections actually have no packet loss. The median was 0. Actually, the 75th percentile was usually 0 too. So the vast majority of connections just don't experience any packet loss. But the average for mobile is 2.5% packet loss, and for fixed it's 2.2. So the implication here, if the median and even 75th percentile is 0 packet loss, but the average is 2.5 or 2.2, it means that connections are usually fine, but when they're not, they're bad. They're really bad, right? Mobile's worse than desktop, but it's still small, right? It's still, most connections are not going to have packet loss, and so you're okay most of the time. So, quick summary on the things that made mobile different from desktop. The CPU difference, it matters. We've got JavaScript taking longer to run on the slower devices. The different network connectivity matters a lot more than the CPU. So we're going to want to focus for sure on network connectivity in our optimizations. Download bandwidth was part of that, because it's slower on the cell networks, but the latency mattered even more, high latency. So anything we can do in our optimization techniques to reduce the impact of that latency is going to help a lot. So that's where we're going to focus. Okay, so a real quick introduction to what we mean by front-end optimization, because this is the whole technique, this is the whole arena. I don't know if, by a quick show of hands, how many people have heard of or know something about front-end optimization? Okay, and then never heard of it before or don't know anything about it. A lot of people didn't raise their hands for either. I did notice that. Okay, this is cool stuff. So this is a waterfall chart. Hopefully you've seen this before. You can get your browser, and there's various tools to look at this. But this is a representation of all the things that go on when you load a web page, right? So you go and you click on www.coke.com, and the page comes up. But of course, as you know, in loading that page, lots of other connections are being made to pull in other resources. And this is a graphical representation of those measurements of bringing in all the different resources. So we call it a waterfall chart. Each horizontal line here is representing one resource that has to be requested and returned from the server. The colors in this particular graph, the orange is the TCP connect time, the green is the request, and the blue is the response. But it depends on what tool you're using. The green vertical bar is important. This is the start render time. So this is when the browser believes that it has begun to show something other than a blank page. It's showing the user the beginnings of content. The blue vertical bar is the on-load time. It's the time where the browser believes that it's shown the entire document to the end user. Now, of course, in an AJAX world, that's complicated. When is the browser ever done displaying content? But this is the point where the status bar, the progress bar, has stopped rotating, and the user has what they need, basically, to work with the page, to interact with it. So we divide this into what we call the front end and the back end part of the session. The back end is everything that's needed to retrieve that first byte and serve it to the end user. And so the back end is mostly made up of the time spent waiting, talking to application servers, or for the application servers themselves to do something, for the databases, for the back end processing, right? Once you get that first byte, everything after that is considered front end. And anything we can do to optimize front end, we can help. The particular reason that we care about front end is because of this. The vast majority of the time that users are waiting for a page is on the front end, 80 to 90% by this metric. So if we want to optimize, front end is where to start, right? Back end, we can get savings, but we'll get the most bang for our buck out of the front end. So the general regime here, this is a typical waterfall chart. The front-end optimization techniques will fall into 3 different categories, generally. One is just to reduce the number of requests. If I don't have to go out over the network and get more stuff, then my page is going to load faster. Another is to reduce the number of bytes that have to be sent, right? And there's a lot of techniques for this, but if I just can make the connection to the server and get less stuff back, it takes less time, page loads faster. And then finally, there's a bucket for accelerating the rendering. Tricks you can do in your code in order to get the page to actually display faster. And there's plenty you can do here. Pages written a certain way will sit and block and show the user nothing for a long time. Other pages, just reworking the way the page is written, will show the user content that's useful, and they can start interacting with the page much earlier. So the net result is to turn a waterfall chart that looks like the one on the left to the one on the right. Fewer requests, fewer bytes, accelerate the rendering, make that page show up faster. Just as a quick aside, there's many, many techniques for this, literally hundreds. We're going to look at just a few that are mobile-focused today, but it's not meant to be representative of everything that can be done. There's a lot of cool tricks out there. So, one side note also, before we get into the actual techniques, which I know is the meat and the cool, fun stuff, measuring. One word about measuring. Measure, please. It makes all the difference. And not only measure, but measure imagining that you are different parts of your end user population, right? Your end users are not only on the coolest phone that you have, they're also going to be coming from slow old phones on slow connections. And there's ways to test these things. There's nice tools out there. Web page test, if you don't know it, check it out. It's publicly available, webpagetest.org. You can run tests through that public page, or you can actually download this as source to install for yourself. It lets you simulate various different browsers loading the page, and it lets you simulate different network connections. So through this, you can say, let me see what it's like coming through a 3G cellular connection on an iPhone 4S. Yes, actually that's right. It's not, there was a correction here that it's not simulating it, it's actually using these devices to render the page and display it. So it's very accurate in terms of what it's showing you. Apple also has a built-in network link conditioner, so you can tell your Apple device, hey, pretend I'm on this type of network. And on iOS 6, it's now built in. You have to have the developer stuff enabled on your phone, but once you do, you can tell your phone to pretend it's on a different quality network and simulate it yourself. You can Google search for how to set it up. But that's pretty cool that they put that on the device. And then one final testing tool, Akamai also has one called MobiTest that's similar to webpagetest.org, but geared towards mobile devices in particular. And this is also open source and available. Okay, so the actual techniques. All right, so one disclaimer. The focus here on the ones we'll look at today are on when you have a dedicated mobile site, meaning redirect to an M.dot site. Responsive web design sites have different considerations to take into account. So we're going to skip all of the common FEO techniques, front-end optimization. If you know these cool favorite ones and you don't hear them, it's not that we forgot, it's just we're focusing on mobile specific. So, first optimization for mobile is around redirects. So we'll look at a waterfall chart. We have a site, we connect to it, and it issues us a redirect. Maybe it's redirect to go to the mobile site itself. mobiledetect.js. So redirects are good for certain things, right? We kind of like this idea of a redirect for mobile that's with JavaScript because you can do client-side browser detection, right? It's much easier to deploy for an application writer than a change on the web server itself, right? You can make Apache do this, but then you have to go talk to the guy that runs the web server. Here, you just do it on your own, right? And it's future-friendly in the sense that you can test other things than just user agent. You could also look at what's the screen size, do other things at the same time. So, okay, this seems like a nice thing to do. A lot of people do it. But it has a serious downside. The downside is this. It's really slow. So, first of all, the redirect is only going to happen after the JavaScript is completely downloaded and executed, right? JavaScript blocks. You have to wait for it to get downloaded. So you've started to load this page. You have to pull in this JavaScript, download it, execute it, and now you say, OK, let me redirect. And on a cell network, that took a long time to do. Not only that, you may have downloaded unnecessary stuff along the way. In this particular example, there was there were some resources above the JavaScript in the HTML. Other things that the page was going to pull in that it would have used for other sites if it didn't have to redirect. But just the way the page was constructed, they did get pulled down. So that delayed your downloading of the redirect. So you're slower to get to it than you had to have been. And some of it may not have, even if you're really clean about making sure that the redirect is the first thing that happens, you can get thwarted a little bit by speculative HTML parsers that might be looking ahead and deciding to pull other things in, in advance that you didn't want loaded in that order. So this causes problems. The solution is fairly straightforward, which is to switch your JavaScript redirect to an HTTP redirect. This is straightforward to do in Apache. You can set some rewrite rules. Your content delivery network can do it as well. Akamai has mobile detect and redirect. Just notice at the edge that it's a mobile device, and boom, redirect to the m.dot site. The CMS or the app server can do it too. And as a fallback, you can put something in your page, but inline it, right? Don't make someone go out and get another thing from the network in order to do that redirect. Put it right inline in the page so that it's fast. So a little look at the results. What have we done? The real page, by switching from a JavaScript redirect to an HTTP redirect, now starts loading after, in this example, 1.5 seconds instead of 5.5. So 4 whole seconds, right? And that's a tremendous difference for someone that's standing there waiting for something to happen on their phone. And this is only the first of a few things you'll probably do, right? So this is a big help. No downloading of extra JavaScript and CSS. This is good across the board. The only downside is, right, if you really liked the aspect of being able to do the JavaScript for the redirect, you're out of luck on that. But sorry. You can also merge the redirect chains, right? 1 redirect is bad, 2 is worse. So it's not uncommon to see a site that starts with a redirect for one reason and then immediately redirects for another. Maybe one of them is for the sake of mobile detection, but another is for the application itself. You're changing from, you know that you're in an administrator context, so redirect to /admin. So first a mobile redirect, and then an application redirect, and now you've killed your performance. So if you can combine these, that's helpful too. A little more tricky, you have to merge the mobile and application logic, but it's usually a doable thing. One other technique for redirects is serving client-specific HTML. You have to be careful with this, but instead of redirecting, return HTML specific to the client, as you've detected on the server. Same URL, different content for what the end user is. It's one of the things you have to be really careful about here is caching. You'll have to tune, if you have a CDN or caching servers, you don't want them to cache one version of the page based on the URL and then have different end users on the wrong device get the wrong page. That would be a disaster. So use this with caution. Okay. Second optimization is compression. So this is an example of a page that's loading without any HTTP compression. You can see the headers here. We have 160 kilobytes of content being loaded. And that's just for a single JavaScript file, by the way. That's prototype.js. And there's no gzip on it, right? It's just bare. There's a little excuse for not using gzip now, right? It's built into most parts of the stack. The application server can do it, the web server can do it, the load balancer can do it, your CDN can do it. You really want to turn this on. And the reason is it has a huge impact, and it has an especially huge impact on mobile. In this example, you can see a page with compression went from loading in 12 seconds down to 6. Right? We cut the time in half to load the page. And this is a graphic visual, a film strip of when the user saw that page, blank screen for half the time. The reason that compression matters more on mobile has to do first with the mobile network bandwidth and latency being worse. So you expect things to be slower on the network, so if you have less stuff to send via gzip, you'll get it faster. But, and this is interesting, mobile websites are more compressible. The content on mobile websites is actually usually more compressible than desktops. The reason is they have fewer images, right? They're tuned to have just the necessary images and not all of the fancy stuff. But if you have fewer images, it means that the JavaScript and the CSS account for a larger percentage of what you're actually waiting for. So therefore, the compression has a bigger impact, right? It's also, it's the case today, in case your concern is that, do the devices support compression? All the mobile browsers you care about support compression. It's almost the case where that's true with desktops as well. There's still some stragglers. So that's it for compression. And I want to stress that one a little bit because it's one of the ones that's dead easy, in a sense, to turn on, but it's also easy to forget. And unless you go and look to make sure that you have it enabled, maybe you don't. And maybe you have a quick win that would let you just get a lot of performance for effectively no work. So I would take a look at it. Third optimization is around images. So images account for usually a very large portion of the bytes on a page, or the bytes that are being downloaded. In this example, 74%. And now that we have Retina displays and everything else, the images are accounting for a really large portion of the images on a page. The usual Retina technique, right, has an image that is double the height and double the width of what the normal image would be, which means you really have 4 times the amount of content that you're loading to get that extra resolution. But of course, 4 times more content means 4 times more stuff to transport over a slow cellular network. So what do we do about images? Well, first, we can do a kind of lossless compression. We can actually compress images without removing any quality whatsoever. The reason is, it turns out there's a lot of data often that comes with the images files that's not related to actually displaying them. This technique is called image minification. We can shed bytes that are, for example, stored in the image for geographical data, right? Or color histogram data, or unused colors that have data included in the image. There's file formats that are more efficient than others, right? All of these will get you to fewer bytes, but without disturbing the image in any way, right? So you can check out smush.it is a website. That one comes from Yahoo. You can plug in images, and it will take out all of the stuff that you don't need to display the image and show you what your savings were. And then in this example, you can see on the Retina image, we managed to get 14% of the data out, and on the regular image, 18%, right? So this is a big savings on a cellular network, right? This is a real performance improvement for nothing. Okay, and then there's lossy image compression. But what do we mean by lossy here? We have smaller devices. They have smaller screens, right? You don't need to download the entire large desktop version of the image just to have it displayed on a small device that can't support all of those pixels anyway, right? So we can call this responsive images, right? Let's take account the size of the screen when we deliver the images and deliver an image that is compressed appropriately to the screen size. Side note, don't forget about CSS background images, right? Those are images too. They have to get downloaded and served, so you'll want to look at compressing those as well. So some example numbers. We start with an image, and it's a high-quality image, and the original is 56K if it's Retina, and 14 if it's regular. So first we can apply the lossless compression, and we see that does a pretty good job. We get either 14 or 18% reduction in the amount of data that we have to send. We bring it down to desktop resolution. Now we have a savings of 53 or 50%. So that's great, and we're still at the desktop. We've saved half, right? And again, on a slow, really lossy cellular network, this is fantastic. But that was still desktop sized. If we reduce it to something 320 pixels wide, now we're looking at having shaved 88% or 50% depending out of the original image size. And if we're down to 128 pixels wide, we've now saved 96% or 85% of the amount of data we had to transfer. So for a mobile site, this is key, right? I mean, this is the difference between many, many seconds of waiting versus not. Just as an illustration, right, you can see the full resolution image. This is taken from Lonely Planet, and then reduced down to different sizes for different screens. You're not making the image any worse, right? The small screen couldn't have displayed anything better, and instead of serving 50 kilobytes, you're serving 2.9 kilobytes, right? You're much happier with this. So, optimization 4, consolidation. I was here for your CSS is a mess talk, and so this has sort of interesting trade-offs with that one. So this is a site that has a lot of different fragmented CSS and JavaScript files. You can see at the top that you've had to load, I don't know, looks like 15 or 20 different files. 2 CSS, and there we go, 16 JavaScript. Remember that each time you have to make a separate request for something, over a connection, you have to go and do that get first, and then wait for the data to come back, which doesn't seem like a big deal, but on the cellular network, you've got hundreds of milliseconds of latency. So just that additional get and request for each of those objects is really adding up to delay. And you have hundreds of milliseconds times 16 files. That's a lot of delay, right? Plus, each time you do one of these requests, you have to have the request header stuff, you have to have response header stuff. So there's a lot of extra bytes that aren't even about the content that you were trying to download, right? So that's overhead, and on a cellular network, all of that matters. So one good technique is to consolidate your CSS and JavaScript files so as not to have all of that extra overhead. Now, you have to be careful with that. For one thing, it's not exactly what you want to do from a development point of view. It's nice to break out into different files, so you can consider at the build time bringing them together and consolidating that way. But even so, you still have things to be concerned about because under the wrong circumstance, consolidation can hurt. It's good for reducing round trips, but if you're not careful, you can make your caching regime worse, right? And by putting everything together, you hurt progressive processing, which is to say, where you could have started showing some content as the page was loading before, now you may need to wait until you have that entire one big CSS file. So consolidate with care, right? This is one where in particular you want to measure and see, did I help or did I hurt? Good techniques here are to merge a lot of small files together, especially if they're functionally related. You think they're always going to be served together. Those are good ones to consolidate. And then the other thing is to defer as much as you can. And this is really getting into the next optimization. But to whatever extent you can put CSS or JavaScript later on, it's going to help not block the browser from displaying what it can as the user is waiting for things to come in. And of course, measure. There is a cool little thing here that you can check out for extra credit. There is a super fancy way that you can do consolidation but not lose the progressive processing. It's called adaptive and streaming consolidation. We have a guy at Akamai who's the total deep expert on FEO, and he put this together, and you can check it out later. It requires serious JavaScript kung fu, but there's something to be done there. Okay, and so the fifth optimization that we'll talk about is deferring JavaScript. So why is this a mobile thing, right? Okay, well, JavaScript blocks rendering, unlike HTML, which as it comes in, you can continue to, you can process it and display it and start working with it. It is a good FEO practice in general to defer the JavaScript for that reason alone, so that you don't sit with a blank page, but have a useful page and then some extra features coming later. But the weaker mobile devices, remember, they're going to take longer to parse and execute that JavaScript. Parsing alone, this is one metric, is about a millisecond for 1 kilobyte of uncompressed JavaScript, right? So, and that's just the parsing, right? That's just taking in the thing to pull it apart and read it and not even worrying about the execution engine part as much. So those weak mobile devices, they're going to hurt on the JavaScript. And then additionally, any of JavaScript you were downloading early on was using network resources that could have been freed up to display the page, right, on mobile in particular. So I'm pulling down at the beginning HTML and JavaScript and other stuff and showing nothing, whereas if I pull down the HTML and wait on the JavaScript, I can start showing that HTML and I start getting it faster. It's also the case that mobile sites, as we talked about just before, are disproportionately JavaScript heavy. They tend to have more JavaScript and CSS and less images. Also, of course, a lot of the common JavaScript files we use are really rather large. 159K, it was 161 on the other slide. So this is going to take you some time to download on a cellular network. So if you don't need it, put it off. Defer it to onload if you can, and you can get away with that a lot more often than you might think. It often has minimal visual impact. This is true on a desktop site, but it's especially true on a mobile site. A lot of the things that JavaScript might be there for might not have any real dramatic effect on the page. A word about external and third-party scripts. These are particularly interesting from the point of view of deferring JavaScript. One is that they can be especially bad for performance. First, you have no idea about the quality of this code and what it's doing, but also you're going and contacting some other site that, it might just be a lousy site with lousy performance. It might be down today, and this is a common problem, right, is to have a web page that's pulling in a third-party resource, and then they're having an outage, or they just have a lousy performance, and then it affects your whole page, and you have bad performance because they had bad performance. So that's not cool. There's a complication here, right? This deferring of where the JavaScript comes at a cost, even aside from just your own functionality, which is scripts that use document.write could get screwed up by this, right? Because they want to shove that data in right when they are getting called, and now you're disturbing that. So you're going to have to be very careful with document.write. Usually something can be done, but you have to watch for it. But the good news is, mobile websites, these complications are not as common. Most of the time, they're not a worry at all. So a little simulation, and in this example, we take the JavaScript actually out completely, and what was a 6.8 second time to load the page becomes a 4.7 second time to load the page. So a really good improvement. And by the way, in our little film strip here, we can see that at the end of loading them, there was no visual difference, right? Those extra 2 seconds were spent for something which didn't have an effect on how the page was going to look in front of the user. Okay, so a quick summary of the optimizations we talked about. First one was redirects, right? They're really costly on a cellular network. All that, you have to process some stuff to get to them, then make extra round trips. Not a good story. So consolidate redirects, move to HTML redirects is HTTP redirects is the big thing, and do it as little as possible. Compression, check that it's turned on, look. If it's not, turn it on. It's a freebie, and it's a big one. It saves a lot on the cellular networks. Images, adapt. If you're on a mobile device, right, you want to be serving smaller images that are appropriately sized and going to take up less space on the network. Consolidating JavaScript and CSS, but do it carefully. And then finally, deferring JavaScript as much as you can, also to be done carefully, but not as worrisome as optimization 4. Okay, so those are the optimization techniques which we think of as being particularly mobile-focused. There's lots more. These are sort of the most straightforward ones. As you can see, the earlier ones are the ones you have to worry about less, and the later ones are the ones you have to do with more care. But let's talk now about automated versus manual front-end optimization. I think a lot of the people here are doing web page coding, right? And so this could be you, right? That wasn't me. Okay. So you have your manual page. It's, you have your original unoptimized web page, and this is your happy hacker. It's really cool to do this stuff. Let me move these things around and figure out how I can make it faster and better, and you end up with this optimized page, and that's neat, and that's fun, and wow, I love my job. But then you realize there's lots of pages, and there's lots of sites, and you have to do this every time you update a page. And your happy hacker becomes this guy. It's not a fun job anymore. It's just a tedious thing, and no one likes it. It's also complicated. This is the world of web browsers that we know today. 5-10 years ago, it was not this bad, but now we have lots of different web browsers that are actually significant players that you have to account for your end users using. And worse than that, you have even more different versions of these browsers out there that you have to worry about. Is my thing optimized in this environment the right way? And then a constant stream of new technologies coming in and out of, well, mostly in, but into web browsers at different times in different ways, right? So this is a graphic representing the different browsers and when they pulled in different features. Nobody wants to account for this, right? I mean, this is a pain. It's hard to even read the thing, right? Let alone try to code for it. And then there's mobile. This is Android. All the different types, right? This is a mess. This is too hard to keep track of on a daily basis for getting your work done producing websites. So, what's the answer? Instead of manual FEO, let's do automated FEO. You have your web server. It produces slow, generic HTML, okay. Add magic pixie dust. And out comes optimized HTML, appropriate for the different browsers and the different circumstances. We can spend more time with the cool picture. No? Okay. So automated FEO, the front end is complicated and it's really hard. And it's easy to make costly performance mistakes without even knowing it. And worse than that, you kind of want to make those mistakes, right? Because they're often good coding practice to have things just clear for the way you create the page and the way that things are organized. But then it can have a big performance cost. If you do decide to do it yourself, the hand maintenance is difficult. it's time consuming and it's expensive, right? You're spending a lot of developer time on that instead of something else. I liken this to writing in assembler. You know, this is like the days where some people would write in machine code and they would have these super optimized programs that were just lightning fast. But then when it came time to add a new feature, they were sunk because you had to just rework everything from scratch, right? This is the moral equivalent of that. You want to work with the tools that you know, producing HTML in a development-friendly environment, and then just have it optimized for you by the moral equivalent of a compiler. Here it's automated FEO. And of course, if you're spending time doing FEO, that's time you're not spending on whatever your core business is. So automated FEO automatically applies the optimizations. It's more cost effective than spending dev time on this. And in particular, this is one of those areas where the techniques are very, very specialized. And there's experts that can do this and can do it super well. But you don't really want to spend a lot of money having those experts in-house, right? It's just not worth it. I mean, maybe if you're Google or Yahoo or Amazon or something, you can do it. But if you're a medium-sized company at all, this is crazy, right? You want to use someone that has professionals that do this for a living 24 hours a day. Well, hopefully less. Okay. So quick summary, takeaways. The big one, mobile environment, unique challenges for optimization. It's not just the same as a desktop site. It's a different beast, and you have to treat it that way. But there are a number of simple optimizations that can really make a big difference. So actually think about it, actually go and look at this and apply it, and actually measure your sites from the different types of end users that you have. And that includes the slow ones on slow links and with slow devices. And then finally, automated FEO, take a look at that. That can give better results than doing it on your own, and it's usually easier and faster and just going to be less overall total cost. Okay? So that's it. And now I'll take questions. Okay, we'll start here.
Hello, Kuba Kociński, hosting team for Procter & Gamble. I have a question regarding the automated way of doing front-end optimization. We've went a lot way from a very unoptimized sites into mobile-friendly and optimized sites. What do you recommend as a framework toolkit for the automation?
Okay, so the question is, what do I recommend as a framework or a toolkit for optimization? I'll give you one guess which my favorite one is, which would be, Akamai. I think that's a good choice. But there are other ones out there as well. The particular benefit, I know it's a big surprise. He said Akamai, really? The particular nice thing about Akamai, though, aside from the fact that we have, we recently purchased this company called Blaze in Canada that has tremendous experts on FEO and the FEO techniques, is that really the super benefit you get is having those FEO optimizations on top of a CDN. So, if you go and look on the web, just Google around for what are the recommended acceleration techniques, optimization techniques for a website, the first one is usually use a CDN. And then it's, okay, I want to add FEO to a CDN. So those two in conjunction do a lot of good, and Akamai, in my opinion, would be the best. There are others, of course. The other thing on that is that there's static tools that will work offline to produce the page. For example, Apache has a plugin module for this. That's not bad, but you won't get the same kinds of performance improvements you can get by doing it at the edge of a CDN, looking at the traffic live.
You were talking a lot about optimizing images, but you didn't mention spriting, which seems to be one of the most common techniques. And I have a really specific question, because I did some research on spriting, and the tools that are available today for automated spriting are really poor on features and on integration. And I was wondering if you are doing some research in predictive spriting. It's a way that you measure what are the patterns in how users use your site, and then you combine the images from different sites, from different URLs, to save on latency, because latency seems to be actually the key. It's usually better to sprite all the images than fragment them into packages because the latency is so much more important.
Right. So just to make sure that everyone's on the same page about spriting. Spriting is one of the cool front-end optimization techniques where you say, hey, it's a bummer to have to go download all of these images individually, the same way that it was a bummer to download multiple CSS files. So instead of making a lot of individual requests, you bundle up all of your different images into one image file that you download, and then use JavaScript to select out, or there's different methods for it, but you select out for display the right parts of the image. So that you'll just see the right things in the right place, but it all came from one image file that was a consolidation of all the other images. So it's a very cool technique. We didn't identify it here because it's not one of the ones that tends to be very mobile-oriented, but it can help on mobile, of course, in particular given the nature of not wanting to go back for multiple requests. With respect to the specific question was, are we doing anything to look at predictive spriting, which is combining not just images on one page, but images across multiple pages to figure out where we could get a performance benefit there and then put them together? The answer is, I don't know for that specifically. I know there's other predictive stuff for sure that we're looking at, and spriting might be one of them. But I do know that the team is aware of predictive spriting, so hopefully they're at least considering it. Any other questions? Yes.
In relation to deferring all of the JavaScript on the page, or as much as possible, I've had similar bursts of optimization over nights and weekends, and I've always had a lot of trouble with the number of add or tracking libraries that are required to be in the top of the page without async or defer keeps growing. Do you have any thoughts or ideas about how to get around that, or is this just let those particular ones, even if there's going to be 200 of them in 6 months, do whatever the hell they want?
Wow, okay. So the first thing I want to say actually, by the way, is that for me personally, in terms of when I am doing coding, I tend to do my late night stuff is like cool new feature stuff, and then the optimization stuff is the drag during the day.
I'm crazy.
Okay, you are crazy. But in any event, the optimization does have to be done at some point. So actually, this is news to me because I'm not actually the deep expert in this stuff. So the aspect that there were ad sites where async didn't work and that was growing. Do you have more details on it?
Sure. So a lot of their tracking and ad libraries require you, or in their documentation, require you to put things as early as possible in page load so that they can inject scripts that check what time they've loaded and can inject just detect where you're moving the mouse on the page and things like that.
I see. Okay.
And that, in my particular life, keeps growing because there are new tracking techniques. Most notably at the moment, Adobe Test and Target. But
okay. Okay. So that's a good question. I don't actually know the answer to that one, but I'd be happy to follow up on that and find out what can be done. Yeah.
So we can now, I think, finish with the questions. Thank you a lot for your talk.